Today on The Explainer, we're diving into a field that honestly sounds like it's straight out of science fiction, but it's becoming science fact faster than you can imagine. Regenerative medicine.
And this isn't some far-off academic dream. Take a look at this number. We're talking about a projected market value of nearly $6.5 billion by 2030. And that's just for 3D bioprinting, one piece of this puzzle. That is a huge amount of money and belief being poured into a technology that could completely change how we think about our health.
So, that brings us to the big question, right? Can we really build new body parts from scratch? It's a wild thought, and believe me, the answer is a lot more complex than a simple yes or no. So let's get into it.
We are right on the edge of a new medical frontier. The promise here is, well, it's profound. The idea of rebuilding, repairing, and even rejuvenating the human body could solve massive problems, like the critical shortage of organs for transplant. But as we're about to see, the biggest challenge isn't just getting the science right. It's building the human trust needed to use it safely.
So what is regenerative medicine really? Well, at its core, it's all about working with the body. Instead of just treating symptoms with drugs or using inert implants made of metal, the goal is to heal from the inside out, using the body's own building blocks, its cells, to restore what's been damaged.
But it's not just about, printing a spare kidney when you need one. A massive driver for this whole field, as you can see here, is actually research. Scientists can now create these stunningly accurate models of human tissues. Think mini organs on a chip. This lets them study diseases and test new drugs with a precision we've just never had before, which means faster discoveries and safer medicine for all of us.
Okay, so how is any of this even possible? What's in the toolkit that's making this revolution happen? Well, it really boils down to a couple of game-changing technologies. We're going to focus on two of the big ones, 3D bioprinting and CRISPR gene editing.
First up, let's talk about the tech that lets us literally build with life itself. Now, you probably know about regular 3D printers that build things layer by layer out of plastic. 3D bioprinting is that exact same idea, but its ink, well, it's a whole lot more interesting.
So instead of a spool of plastic, bioprinters use what are called bioinks. These are usually gel-like substances called hydrogels. They're mostly water, which cells love, and they are packed with thousands upon thousands of living cells. This is the actual raw material for building new tissue.
Right, but you can't just squirt living cells into a dish and expect them to become a liver. They need a structure to grow on. That's where biomaterials come in. They create a scaffold, kind of like the frame of a house. This scaffold gives the printed cells the shape and support they need to organize and mature into a real functional piece of tissue.
The whole process is, as you'd expect, incredibly precise. It all starts with a digital blueprint, maybe from an MRI or a CT scan. Then the bioprinter gets to work, carefully printing the bioink layer by tiny layer. And finally, this new living structure gets moved into a bioreactor, which is basically a high-tech incubator that mimics the human body to let it mature into living, working tissue.
And this is what makes it a total game changer. Think about it. We're moving away from putting inert mechanical parts, like titanium hips, into the body. And we're moving towards creating living, biological solutions that can actually integrate with you, grow with you, and function as a part of you. Now, for the other revolutionary tool. If 3D bioprinting is the architect, the builder, then CRISPR is the editor. It's an amazing technology that gives scientists the ability to go into our DNA, find a specific gene, and change it. It's literally like having a find and replace function, but for the source code of life itself.
And the potential here is just staggering. For the very first time, we have a tool that could theoretically go in and fix the root cause of horrible hereditary diseases, things like cystic fibrosis, sickle cell anemia, or osteogenesis imperfecta that are caused by just one faulty gene. It offers a kind of hope that just didn't exist before.
But, and this is a big but, with power like this comes an immense responsibility. And like with any huge technological leap, the path forward is often littered with cautionary tales, where the hype and the promise get way, way ahead of the science.
And here's where the story takes a really sharp and frankly dark turn. This quote highlights a real case where a patient was seriously harmed by an unproven stem cell therapy.
We're not talking about the careful, controlled science anymore. This is what happens when that science is misused.
And this wasn't just a one-off tragedy. It became a heartbreaking global pattern. You had patients harmed in Japan, the massive Stamina Foundation fraud that rocked Italy, and even patients here in the US who were blinded by unregulated clinics peddling so-called miracle cures.
So you see the problem, right? In the shadow of all this amazing scientific progress, a dark market pops up. You have these unregulated clinics that prey on desperate people, charging a fortune for therapies that are unproven, often contaminated, and they lead to just devastating results. Blindness, paralysis, even death.
And maybe the most infamous case of all was the Stamina Foundation in Italy. Get this, the scientific evidence they submitted to health officials to justify their whole operation was reportedly written by a medical student who allegedly used Wikipedia as a primary reference. It's just a shocking example of how easily the language of science can be twisted for profit.
Okay, so after hearing all of that, you have to ask, how do we move forward? How do we get all the incredible benefits of this technology while protecting people from the fraud and the harm? Well, the answer isn't to hit the brakes on innovation. It's about building a rock-solid system of trust around it. It's making sure it's all done the right way, based on hard evidence, rigorous safety protocols, and total transparency. That's how the real breakthroughs happen.
And at the absolute center of that safety framework is one key idea: biocompatibility. It's a fancy word for a very simple but absolutely vital question. When we put something new into the human body, will the body accept it, or will it see it as a foreign invader and attack?
And this is how the real pros do it. This flowchart shows the international standard, ISO 10993. It's not just some simple checklist. It is a comprehensive, step-by-step risk management process that starts by analyzing the basic chemistry of a material long before it ever gets near a person. This is what separates legitimate science from dangerous malpractice.
This right here, this is the blueprint for trust. It's what allows scientists and doctors to push the boundaries responsibly. It ensures that any new treatment isn't just revolutionary in its promise, but that it's also proven to be effective and, most importantly, safe.
So here we are. We've got this incredible new toolkit with the potential to cure the incurable and rebuild our very bodies. But as we've seen, it's a double-edged sword. The regenerative revolution is here, absolutely. The real question is, what will we as a society choose to build with it?